So it's just a list of numbers. So we've got two different types that we're going to talk about. You've got arithmetic and geometric. So today we are just focusing on arithmetic sequences. So an arithmetic sequence is a sequence in which the difference between any two consecutive terms is constant. So essentially there's adding or subtracting some number each time, over and over again. I'm going to write all that up here, yeah. So the common difference is the numerical difference between any two consecutive terms. So it's that number that was added or subtracted each time. That's just what we call it. So if you're asked to find the common difference, that's essentially just what did they add or subtract each time. Yes. Why is it like what? We all right so far? Alright, so again, your arithmetic sequences are going to be adding some number each time. So we're going to look at these sequences below and then decide if they're arithmetic or not. And if they are, we're going to tell what the common difference is. So if we're looking at the first one here, we have 1, 5, 9, 13. So what do y'all think? Is that adding some number each time? It is, right? It's adding 4. So we'll say yes, it's arithmetic. And that common difference, the number they added, was 4. Alright, so look at the next one. We have 1, 3, 5, 8. What do you think? How do we go from 1 to 3? And 3 to 5? 5 to 8? So they added some number each time? No, so this one is not an arithmetic sequence. What about number 3? 8, 6, 4, 2. Okay, so we'll say yes, it's arithmetic. and your D value is going to be -2 because they were subtracting. All right? Your common difference. All right, looking at number 4, we have -5, -8, -11, -14. Are they adding some number each time?
No.
How do we go from 5 to 8? 8 to 11? 11 to 14? So is it some constant difference each time? Right, so it is arithmetic. It's just negative, so that D is going to be -3. That okay? What about number 5? Why not? What are they actually doing? Multiplying. So we're going to do that tomorrow. That's going to be a geometric sequence. So we are multiplying by something each time. For number 6, we have 6, 7, 5, 4. What you think? Yeah? Good. Questions? Alright, so we are given some sequences and we need to find the next 3 terms. So you've got to figure out like what they're adding and then continue to do that. So we have 9, 13, 17, 21. What are they doing each time? Adding 4, y'all agree? So add 4 to 21, what's going to be next? Add 4 again, what do you get? Add 4 one more time. Here we go. Is that okay? Alright, next one. We got 5, 2, -1, -4. What are they doing? How do we go from 5 to 2? Subtract 3. So if we do -4 minus 3, what do you get? -3 again. One more time. Is that alright? Okay. So, if you want to find the nth term of a sequence, they have a formula that will help you get there. So, like, if you want to find, oh, sorry, we skipped number 9. I was getting way ahead of myself. Number 9. -8, -2, 4, and 10. What are they adding each time? 6. So, add 6 to 10. What do we get? 16. And add 6 again. And one more time. There we go. Are we okay to move on now? Sorry. I jumped the gun there. So if you need to find like the next 3 terms, it's super easy to just keep adding, right? But what if I asked you to find like the 100th term? Do you want to write out 100 terms and like add 6 100 times till you get to what you need? That sucks, right? That's awful. What if you had to find like the 1000th term? That'd be even worse, right? So there's a formula that you can use to avoid all that. So you can find just the term that you want. So that formula is A sub n. And so that n just represents what term number you want. Equals d times n minus 1 plus a sub 1. So again, n is your term number. The D is that common difference. So like what we were finding before, what they add or subtract each time. And then the A sub 1 is the first term of your sequence. We all right so far? Questions on anything? All right, so we're going to go apply that to these two. So we want to write the rule for the nth term, and then we're going to find the 19th term. So we're going to write our general rule first, and then we're going to plug in 19 and figure out what that would be. So you've got to find your first term and your common difference before you can write your general rule, right? We have to plug those two things in. So your first term, super easy. What is it? 7. Is that okay? Just whatever the first term in the sequence is. Then our common difference, we've got to figure out what they're adding each time. So from 7 to 13, what they add? 13 to 19? And 19 to 25? So your common difference is what? 6. So we're going to take those two things and plug into this formula up here. So we're going to say A sub n equals D, but in place of D, what are we putting? 6. We'll leave the n minus 1 in there. And then plus our first term, so plus 7. Is that okay? So then we're going to simplify that just a little bit. What could we do right here? Distribute. So that's going to give us 6n minus 6 plus 7. Combine your like terms. So that's just the nth term. So it's like a placeholder for whatever term number you want to put there. No. Nope. It's just a term number. Is that okay? So like if your sequence is, what do we have, 7, 13, 19, 25. The first term is A sub 1. The second term would be A sub 2. The third term would be A sub 3. The fourth term, does that make sense? Is that okay? Correct. You would put 1,000. We want to find the 19. So what are we going to put? 19. So we're going to do A sub 19 equals 6 times n. And what was the n that we replaced? 19 plus 1. Is that all right? Yeah?
So you just, the number that you're trying to find is what you plug in for the end.
Correct. Any other questions right now? So what is 6 times 19?
No, 114.
114, add 1. So your 19th term is 115. Is that okay?
Yeah. I'm just trying to remember the formula. So if you write like A percent, but yeah.
N?
N or whatever.
We would say A sub 19 equals 115. That would be like your answer or whatever. Is that okay? Questions? What is all this? Yeah. Is it alright though? Because it's not like too bad. I think it's just a lot at once. So do we have any other questions right now? Okay, so let's try the next one. So we got to find our first term. So what's the first term of this sequence? So A sub 1 is 30. Then we've got to find our common difference. So what did they add each time, or subtract? Negative 4. We all right with that? Are we good with finding the D? So then we're going to plug into that formula again. So you're going to have A sub n equals, in place of D, what are we putting? Negative 4. Then we're doing n minus 1 plus your first term, which is 30. So from here, what do we do? Turn off our phone. Let's do what? What do we do? Distribute. So negative 4n plus 4. Oh, I didn't write it in. 4n plus 4 plus 30. Then combine your like terms. So we'll have negative 4n plus 34. So that would be like your rule for the nth term. So if you were asked to just get that, that's where we would stop. Is that okay? So then we need to find a sub 19. So we're going to replace that n with what number? 19. So a 19. And then we're going to have negative 4, and in place of n, what are we putting? 19 plus 34. What? Basically it. All right. Questions? All right. So can we just pause for one moment before we move on? When we got our like rule for the nth term, what does that look like? Looks like y equals mx plus b, right? So your slope is your d value, right? So if you can recognize that, it might help you get to answers quicker, especially if it's multiple choice, right? So if you know, oh, well, my common difference is 6, so I need an equation that has a slope of 6, stuff like that will help you out. Huh?
So like on the first one, y would be 1, 3 would be 1, and 2 would be 1.
Right, yeah. Which is not in your sequence, but you get there from the rest of the stuff. Are we okay?
The D
Is like your slope. Are we okay? And like if you think about it, slope is how you change each time, right? You go up however many each time. And we said that's exactly what you're doing in your sequence. You're going up 6 each time. You're adding 6. So that's where that all starts to connect back. Alright, so are we okay with these two?
Yeah.
Yeah? Alright, good. So you've got 4 more. Can y'all try them on your own? Yeah, so you're going to write the equation. So this is called, I'm going to write our formula again over here. This is explicit form. So if you're ever asked to write the explicit form of a sequence, that's what it wants. And minus 1 plus a sub 1. This is your So we want to write the explicit form for all of these, and then we want to find, do y'all still want to do the 19th term, or do you want to pick a different number? Different numbers? Okay, so pick a number for 12. The second, no, it's got to be bigger than 4. Pick a number, any number.
8. 6.
All right, pick another number. A big number.
18.
All right, pick another number, big number.
28.
I heard 23 and I heard 28, so we'll do those two.
Oh man, I'm gonna say.
Oh, I wrote that backwards. A 23 equals. I put the equals on the floor. So we're going to do the 8th term, the 18th term, the 23rd term, and the 28th term. I think you like the number 8. Alright, so again, you're writing the explicit form of the equation, or for your sequence, and then you're going to find whatever term number we said. That okay?
Okay.
Alright, cool beans. Go, go, go. Let me know if you have questions.
All the other stuff
Huh?
stuff I've been like the past week.
Geometry?
Yeah. So you don't have to divide.
Alright, so, for the first one, can we just say what we ended up getting for like our rule? Is that enough?
Like
Or do we need to go through all the steps?
We know how to do it.
Yes, this is our rule?
yeah.
Okay, so you plug in at 8. What is 3 times 8? 24 minus 14. So your 8 term is 10. Yes? We all good? Great. So for number 13, your rule should have been 2n minus 4.
Yep.
So plug in 18. What's 2 times 18?
36.
Minus 4.
32.
Are we all good there?
Yeah.
Okay. So for 14, what was your rule there? Anybody?
Oh,
Sorry.
negative 5 and minus 1.
There you go. Minus 11. So when we plug in 23, we're going to do negative 5 times 23 minus 11. What do we get?
Negative 1.6.
All right. And then for the next one, a sub n equals what? Is that all right?
Yes.
Okay. So negative 9 times 28 plus 110. I have no idea what we get there.
Negative 42.
Is that okay? Are we all right with those?
Yeah.
Questions on anything?
Nah.
Okay, so we've got 2 more. So this is like real life how you might use these. You visit the Grand Canyon and drop a penny off the edge of the cliff. The distance the penny will fall is 16 feet for the first second, 48 feet for the next second, 80 feet for the third second, and so on. Write a formula to represent the sequence. So I don't know about y'all, but I think it's helpful to like see it. So let's write it. Is that okay? So it said 16, and then how fast does it go? Or how far? 48, and then what? 80, and dot, dot, dot. Is that okay? That's all it gave us. So if we want to write a formula, what 2 things do you need?
Your A1.
What is our A1?
16.
16, wherever you start. And what else do you need?
Your difference.
Your difference. So what are they doing each time?
Adding 32.
How could you find that if you weren't sure? Subtract. So like 48 minus 16, or 80 minus 48. Is that okay? So we've got those 2 things. So you're going to have a sub n equals, then what do we put?
No, 32.
32
Is that okay?
Yeah.
All right, distribute. Simplify, clean this up a little bit. What are we going to end up with?
32 n minus 32.
that okay?
Yeah.
Alright. So that would be like our final answer there. The next part wants to know how far the penny will have traveled after 6 seconds. How are we going to figure that out? Exactly. Plug in a 6 for n. So we're going to have a sub 6 equals 32 times what in place of n? 6 minus 16. Type that in your calculator. Let me know what you get.
176.
Y'all are so quick. I hadn't even finished writing it. Is that okay? Questions? So really not too bad, right?
Pretty slow. Pretty slow.
Okay. So next one. The total bank loan for Sarah's new car is $15,265. The bank automatically withdraws $295.80 each month to pay off the car. Huh? That's real life, y'all. That was literally me in college. This much for my car. They took this much money from me every month. I mean, it was pretty dang close. I think mine was just like 15 even though. And it was like $300 a month. Anyway, I did. My car's all paid off now. Anyways, yeah, except I'm a girl, but it's fine. Anyways, write a formula to represent the sequence. So, we don't have a bunch of terms to write out, but do we really need it? So, what would our A sub 1 be?
15,265.
Whatever you start at, right? And if they're taking out $295.80 each month, that's your D, right? Negative. Why? Exactly. They're taking it out. You have to pay that money.
If that's in college, then I feel sorry for myself. Miss V, thank you so much.
I did. I survived.
Did you have a job in college?
I had 5 jobs in college.
5? Like all at the same time?
Yeah.
What'd you do?
A bunch of math, actually. It was like 4 different kinds of tutors and a TA, so all math. Oh no! Math!
Sierra's like, maybe I can make it. Yeah.
No, math. I was a math tutor, independently, small groups for the math department, and then I taught calculus. So, goodness. No, it's not about that life. Yeah, this was going on YouTube. It's fine. It's fine. Let's write a formula for this. We're gonna have A sub n equals what? 295.80, and then in parentheses, n minus 1, and then add what we started with. 1, 5, 2, 6, 5. Is that all right? So we can simplify that a little bit. So distribute, then combine your like terms. If we want to know the balance of the loan after 2 years, how are we going to figure that out?
But we keep on popping up on your screen.
Whoa!
It popped up once already. I'll say it popped up.
Are they doing it every year or every month? So what does N need to be?
12.
Why is it 24?
Because we have
2 years. 12 times 2? 12 months in a year? That okay?
Dang, you're smart, dude.
So plug in 24. Oh, I keep doing N instead of the actual number. Questions on that?
We're all good?
Hey, that's fine.